On the first one, it says that a line passes through the origin and the point a, 10. And it says it forms an angle of 26 degrees with the x-axis. And so I want to find the coordinate, missing coordinate of point P. So one thing I'll notice here is that if I drop a perpendicular, it makes a right triangle. I know this side length is 10. This side length is 10. This side length is A. And so I know that the tangent of 26 degrees is going to be equal to 10 over A. And so if I multiply by A on both sides, I'll get A tangent of 26 degrees is equal to 10. And then I can divide that over. I get A is equal to 10 over tangent of 26 degrees. And if I plug that into my calculator, make sure I'm in degree mode when I do that. I get 20.05. 20.50, sorry. Okay. Number 26. It says we have tangent theta is 28. I need to find theta, an angle in a right triangle. Give your answer in degrees rounded to 2 decimals. So I'm going to just do tangent inverse in my calculator. Tangent inverse of 28 and see what my calculator gives me. I got 87.95 degrees. And it says that the angle theta is inside of a right triangle. So that's theta. This is a right triangle. So I know that that must be something between 0 and 90 degrees. And I can see that the answer that I got is within that range. So I'm done. Number 27 says given A is 10 and C is 12, find the missing side and angles in degrees of a right triangle. And I think typically when we label a right triangle, we label C as the side that's across from the right angle, and that's what it says here. C is across from the right angle, so I'm going to label that 12. And then I'm going to label this, either one, I could label 10 as side A, and side B is what I don't know. So I can find side B, and this is angle B, and this is angle A. Okay, and so side B I can find because I know that 10 squared plus B squared is equal to 12 squared. So I can find side B. And I get that B squared is equal to 44. So B is equal to the square root of 44, or I could write that as 2 square roots of 11 if I want to. So that's side B. I know that angle A, I know that cosine of angle B is equal to the adjacent over hypotenuse. So B is equal to cosine inverse of 10/12. Does it say it wants the angles in degrees? So we'll do cosine inverse of 10 divided by 12. That gives me 33.55 degrees. 33.55 33.56 degrees. Oh, round to 1 decimal, 33.6 degrees. And then I can find angle A because I know that angle A plus B plus C needs to equal 180 degrees. And so I could subtract that from 90. Angle A is equal to 90 degrees minus 33.6 degrees. I get 56.4 for that. Okay, so on the next one, it says I'm given a figure here, and I know the angle of elevation from the bottom of the building to the top of building B is 48 degrees. So let's label that on our picture. From the bottom of building A to the top of building B is 48 degrees. 48 degrees. When standing on the roof of building A, the angle of elevation to building B is 32 degrees. So that means that if I put a dotted line here, that this angle is 32 degrees. And then if the buildings are 300 feet apart, how tall is building A? Okay, so the first thing I could do is I could find the height of building B by using this triangle. I know I have 300, so I'm just going to write it over here, 300. This is the height of building B, and this is 48 degrees. So I can use just this part of the triangle. I'll make it in red. Use this triangle here to find the height of building B. So let's do that. I know that tangent of 48 degrees is equal to B over 300. And so I know that B is equal to 300 tangent of 48 degrees. Oops, that's a degree symbol. And so that is 333.81. 18, I mean. Round to the nearest foot. So 333 feet. Okay. And now I know that height. The next thing I could do is I could look at this triangle here. That green triangle. So let's think about that green triangle. So I have 32 degrees and 300. And I'm going to call this height H. And that's like this height, this part of my building. And so I know that tangent of 32 degrees is equal to H over 300. Or in other words, H is equal to 300 tangent of 32 degrees. Whoops, 32 degrees. And so if I type that in, I get 187.46. Okay, and so I know that the height of building A is going to be equal to B minus H. So B is that whole height of building B, and H is this bit. So if I subtract that off, I'll get the height of building A. So the height of building A is going to be equal to 333 minus 187. Okay. The next one, I want to solve some trig equations. So I want to find some approximate solutions to this on the interval from negative 2 pi to 2 pi, and I want to round that to 2 decimal places. Okay, and so the first thing I might do is I might find the inverse cosine in my calculator of negative 0.43. And if I do that, and notice here that the angles that are measured are in radians already, so I'm going to make sure that my mode is switched to radian mode for this question. And so I'll do cosine inverse of negative 0.43, and that gives me 2.015. I want to round to 2 decimal places, so 2.02. Okay. And if I think about where that is, that's going to be in that second quadrant. So if this is cosine is negative 0.43, that's the x coordinate. Okay, and so that means I'm here, negative 0.43, and then this is my angle in the second quadrant. But I also know that I have this corresponding reference angle here in the fourth quadrant. Okay, and so what will that one be? So I know that this angle here is 2.02, but I know this angle here with the red terminal side is going to be 2 pi minus 2.02. And so if I do that, because 2 pi would be all the way around, but then I'm going back 2.02. So if I do 2 pi minus 2.02, I get 4.26. So this is 4.26. Okay. And so I think I'm ready to write them down now. I want to do everything between negative 2 pi and 2 pi. So I have two positive angles. So I have 2.02. I have 4.26. And then if I go backwards, what is this angle if I go backwards? That's negative 2.02. And this angle here going all around to that, what is that? Well, that's going to be negative 4.26. Okay? So I'll write those down as well. So those are my two solutions. My four solutions, really. And I can see why there would be 4 solutions on the interval from negative 2 pi to 2 pi, because if I draw out the graph of cosine, what's the graph of cosine look like? It looks like this. And if I think about when the x-coordinate, when the cosine value is negative 0.43, that's here. And I want to see how many times does it hit my graph. There, 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 and there. And so those are where my solutions are. Those correspond to my 4 solutions that I graphed on my unit circle. So for the next one, it says I want to find all the exact solutions to this one. So we'll need to do a little bit of algebra here to find out what's happening. So the first thing I want to do, I'll just write out the problem just like it is. So I've got 5 sine theta minus 1 equals 3 sine theta minus 7. And so I can start by distributing the 5. So I get 5 sine theta minus 5 is equal to 3 sine theta minus 7. And then I'm going to move the things that have sine on it all to the same side, and I'll also move the things that are just numbers over to the other side. So we'll do that. So 5 sine theta minus 3 sine theta is 2 sine theta is equal to, and if I add 5 to that, I'm going to get -2. So I get sine theta is equal to -1 when I do that. And if I remember what sine theta means, sine theta corresponds to the y coordinate on my unit circle. So when is sine theta equal to 1? -1. Well, when is the y coordinate on the unit circle equal to -1? Well, it's down here at the bottom. So at this coordinate, that's when the y coordinate is -1. There's only one place where the y coordinate is -1, on the interval from 0 to 2 pi. So what angle does this correspond to? Well, this corresponds to, this is pi over 2, 2 pi over 2, this is 3 pi over 2. For the next one, it says find all exact solutions to this thing here. So let's spend a little time with some algebra on this. Cosine theta is equal to 1 over 4 cosine theta. So I can multiply both sides by 4 cosine theta, and I'll get 4 cosine squared theta equals 1, and I can divide that over. So I get cosine squared theta is equal to 1/2. And then I can take the square root of both sides. So I get cosine theta is equal to plus or minus square root of 2 over 2, square root of 1/2, which is plus or minus square root of 2 over 2. And it doesn't specify whether I want my solutions to be in degrees or radians. So I'm just going to go ahead and write my answer in radians, but you could just as easily write it in degrees since it doesn't specify here. And so if I think about angles that have cosine value, square root of 2 over 2, I'm going to draw a unit circle. And the cosine, remember, corresponds with the x coordinate. So I'm looking for all the angles that have x coordinate, square root of 2 over 2, or negative square root of 2 over 2. And what I get is I get 4 angles. And if you've spent some time with your unit circle, you know that that happens at pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 are my angles between 0 and 2 pi. But I want all exact solutions to that. And so what I need to do is I know that each of these are going to be to appear every 2 pi radians because the period of cosine is 2 pi. So it's going to repeat itself every 2 pi. Or another way to think of it is if I'm on my unit circle, if I go around another full rotation, I'll land back on that same point with the same cosine value. So our solutions are theta equals, and I'm going to have 4 solution sets, pi over 4 plus 2 pi r, 2 pi k, and then I'll have 3 pi over 4 plus 2 pi k, and I'll have 5 pi over 4 plus 2 pi k, and I'll have 7 pi over 4 plus 2 pi k, where k is an integer. It could be positive or negative. Okay. Last one says water temperatures in a lake rise and fall in a 24-hour cycle so that the minimum temperature is 45 degrees at 4 a.m. So I'll just write 4 a.m. here. And that's 45 degrees. Put a dot there. And then the maximum temperature is 55, which occurs at 4 p.m. Okay, and so let's see here. So then it says when is the temperature 50 degrees Fahrenheit? Oh, so that's going to be the midline of my sinusoidal function. And so I know that it's going to go through that midline halfway in between when it has its max and its min. And so halfway between 4 a.m. and 4 p.m. is going to be 4 a.m. plus 6 hours. So that's 10 a.m. And so it's going to go through the midline there. And so in this one, I don't actually have to find the formula for that sinusoidal function. I can just say well, it's going to go through the midline halfway between the min and max, and so that's at 10 a.m.